Okay, so our contract is pretty useless at the moment. We need to add a function to it. There are two types of functions, those that change state and those that only read the state. The non-state changing functions are called view functions. They are completely different from normal functions. Think about it this way. If a view function doesn't change the state, then there's no point even sending a transaction to it. All we are doing is reading data. So for a normal function, someone has to sign a transaction with its private key, send it to the smart contract, and wait for it to be included in the blockchain. For a view function, you don't even need a private key. You're just looking at the data. So let's look at a simple view function here. This function, getRandomNumber, is a view function. So we have to declare it as view. It's also public. We'll talk in a minute about what public means. And it returns an unsigned integer, meaning a positive number. And then we just return 9. Okay, this might not be the best true random generator, but we just want something easy to understand for now. Now, if you add this to Remix in our contract, you can see the compiler is giving us a warning here. And it says that the state mutability can be restricted to pure. So let's change the view to pure. Pure just means it's a special type of view function that doesn't even read any data, because here right now we are just returning 9, and that's not reading data anything from the contract. So in this case, we use pure instead of view. Most of the time you will probably use the view keyword though. You can even return multiple return values like shown here, and they don't even have to be the same type. So that's how you write the view functions, but those are not as interesting as normal functions that actually change state. So let's look at a normal function. Okay, so this is a normal function. The function pay me back less. It basically takes ether from users and pays them back a lot less than what the users sent. A money-eating function in a way. And here we are doing multiple things. So first of all, the function is now not a view or pure function anymore. So we can change state in the function. And then it's also a payable function. If you declare this as payable, anyone calling this function can optionally send ether funds along with the transaction. And then the amount of ether sent is accessible in the function with this msg.value. And the address that currently is calling this function is available with msg.sender. So we first get a random number, then calculate a refund amount by dividing the sent ether by this random number. In our case, that's just dividing by 9. And then to use the special transfer function in Solidity, we need to convert msg.sender into a payable address. We'll talk about this address type later in more detail. But one thing you should know is that this transfer is actually not recommended to still be used anymore. We'll look at how to do this in the recommended way later in the course. And note that when you send ether along with a function call, the amount goes straight into the contract. So let's have a look at how this looks exactly. So let's assume before the call the contract has 0 ether balance. Now someone calls pay me back less with 1 ether. Immediately at the start, the 1 ether will be added as balance to the contract. Then later, when we call transfer, the 1 ether balance of the contract is used for this transfer. And since we transfer essentially the amount we sent, msg.value divided by the random number, which is 9, means we are sending back 1/9 of an ether. So about 0.88 ether is left after the function call.